This is the interim presentation for ME 452 by Team 1, Analysis and Redesign of a Manual Juice Press. The manual juice presser is a tabletop device used to extract juice from fruits such as lemons, limes, and oranges. The user places a pre-cut piece of fruit into a perforated press cup and pulls down on a lever arm which amplifies the applied force and allows the pressing head to squeeze the fruit. The extracted juice flows through the holes into a container below, while seeds and pulp are retained in a strainer. A manual juice press is a widely available consumer kitchen product, sold through global retail and commercial supply channels. Market forecasts estimate that low-cost products, typically $20 to $80 per unit, are to have an annual production of 500,000 to 2 million units per year. The primary consumer group is household users who use the product in their kitchens to prepare fresh juice. These users primarily value ease of use, affordability, compact size, and easy cleaning. The secondary consumer group is small commercial users, such as cafes or juice bars. These users place greater emphasis on durability, efficiency, and the ability to withstand repeated daily use with higher throughput. The exploded view is shown here and consists of 18 unique parts including fasteners. On the next page is the BOM. This slide shows the BOM for the manual juice presser, which consists of parts that are injection molded, both sand and die cast, and machined. The total unit cost of the assembly is $45.95. The cost of a manual juice presser on the market ranges from $58 to $400, with a rough median price of $120. This would mean the cost to make this product is 38% of the median selling price.
The function of the mechanical juice press is to extract the juice from the user's choice of fruit. The first primary basic function is to hold the fruit, which is accomplished by securing and then positioning the fruit in the desired location. The second primary basic function is to separate the juice by removing the pulp and retaining the seeds in the device. The juice press will assure dependability to the users by eliminating any splash the fruit may excrete by guarding the exposed end of the fruit and then channeling the juice. The juice press will also assure dependability by maintaining its structural integrity over numerous uses. To provide convenience to the user, it will have an adjustable height to allow for many different cup sizes to be used to catch the extracted juice. By adjusting the capacity and size of the holder, the juice press will be enhanced to be able to accommodate for many different sizes of fruit. And to please the senses of the customers, it will enhance its aesthetics visually to appeal to the user.
Going into the assembly sequences now, assembly sequence 1 starts with the base, into the anchor and bar, into the holder and the rubber handle cover, and the funnel. Then into the bracket and the sleeve, finally with the handle and linkage assembly with the handle knob joint and reciprocating link and links, and finally into the movable jaw with the strainer as well, comprise the completed press. Assembly sequence 2 has a bunch of sub-assemblies starting with the base and spine, which has the base, anchor, bar, and toes. Subassembly B, the press cavity, has the holder, rubber handle cover, funnel, strainer, movable jaw, and the reciprocating link. Subassembly C, the upper pivot, has the bracket and the sleeve. The handle subassembly has the handle knob joint, and link. And then there is one final step to adjoin all the subassemblies, which comprise the completed press. And here's our comparison table of the two sequences. And while sequence 1 did score higher than sequence 2 in the ease of transferring and handling, as well as the ease of locating parts category, sequence 2 performed a lot better than sequence 1 in the ease of testing subassemblies as well as assembling in parallel. And for that reason, we will be going with sequence 2.
Functional component mapping matrix shows the functions of each component or assembly in the juice press. Each component has a minimum of 1 and a maximum of 3 functions correlating to it. This verifies that every component on the juice press has a critical and functional role to the task.
The quad chart classification for DfM ranks an item's manufacturing cost and functional importance. Each item in the bill of materials is color-coded, and this corresponds to its position in the quad chart.
For the product family, the functions that would be different between the primary and secondary customers were determined to be supporting capacity, maintaining integrity, and enhancing aesthetics for comfort during repeated use. Our suggestions were a redesigned base and handle for increased stability. This is represented by designating the base assembly and the handle knob and covers as modules.
The CAD redesign between the primary and secondary customers focuses on, for the base, redesigning the area to make it more stable, and for the handle, improving the ergonomics by adding ridged grips for your finger. The square on the base is a common interface. It's the same size and accepts the same size bolt. The hole for the grip is also the same size, and it allows easy interchangeability.
Now we will move on to the product family assembly diagram. On top, as you can see with the original sequence, each variant goes to the full parallel subassembly line. Because the base, holder, and handle differ between household and cafe variants, this identity is locked in from the very first subassembly, forcing 2 separate manufacturing lines. In the modified sequence below, we pulled all of the common parts, anchor, joint, bracket, and the linkage of these into a shared platform that gets built first. At the differentiation point, the line splits and the variant-specific modules, base, press cavity, and handle, are added last through these common interfaces. This lets us run a single platform line and branch off at the end, which cuts over, changeover, and tooling costs in half. Thank you for watching our presentation.